Good morning, everybody. Good morning, Michelle. There's Michael. Michael. I hope I got it right. But anyways, good morning. Hopefully you're ready for an exciting morning with me. So let's get started. Good morning. Welcome to Chem 1211 with your host, me, Dr. White. You notice when I do that, my eyes open up? Anyways, good morning. I like to say thank you to everybody. I see everybody. And before I do that, let me just check something real quick on the internet. And I just checked and I was correct because I didn't want to make a mistake. And why did I check? Because I just wanted to look at something. And now I can say, you people have been very nice to me, and I really appreciate it. So next Monday, take the day off. Just take the day off. Tell them Dr. White said you could take the day off. Really, no office hour, no classes. Just take the day off. It's Labor Day, and the school will be closed, and I won't have class on next Monday or lecture on Zoom, and I won't have my office hour either because I'll be with some friends celebrating Labor Day. All right, that's one thing. Now, on a more important note, yesterday afternoon, I got an email from the faculty member who's in charge of 1211 online, and there's a form I'll be posting on Blackboard that you need to fill out, and where you just have to sign it and date it in two places. Scan it or take a picture. I'll put the procedure, and also if you don't know how to do that, I also have an app you can use for your phone. Blueberry tea is good. And you'll need to get that uploaded as a single PDF file sometime next week. Also, the lab, safety lab, remember that's due next Tuesday. And also, don't forget, if you haven't ordered your kit, hopefully you got it. So with that, I might as well start with one more thing. Any questions? Looking at chat down there. All right, let's get back to work. Now, I had been talking about subatomic particles, the particles that make up an atom, which you should know are the electrons, protons, neutrons. Again, electron has a negative charge, proton has a positive charge, neutron has no charge. Now, I talked about Rutherford's gold foil experiment, which showed that the nucleus is very dense, I mean really dense and tiny, and the electrons are on the outside, and inside the nucleus, which is the center of an atom, we have the protons and neutrons. Again, nucleus, center of an atom, have the protons and neutrons, and outside are the electrons. And I'll teach you later on, I don't think it's the next chapter, not this one, I might be wrong, that the electrons are in what we call the electron cloud. Now, how dense is the nucleus? I didn't share this with you. If the nucleus were the size of a softball, the electron cloud for a typical atom would go 1.5 miles that way, 1.5 miles that way. It would be almost 3 miles in diameter, while the nucleus is only this big. It's dense. The nucleus and the electrons are spread out, and That's why they call it a cloud, because if you look up in the sky, I'm in my office, I can't look up at the sky, but pretend I could, and you could, you'd see clouds, which are water vapor, but very low density. Now, an important concept you should know, hint, see, it even says it on your screen. Oh, that's hokey, but it works. Know this. And we're talking about the atomic number and mass number. Now, the more important for this class is the atomic number. And the atomic number tells you the number of protons in the nucleus. By definition, the atomic number tells you the number of protons in the atom. I say nucleus, but well, they're in the nucleus, but it's total number of protons in the atom, which happens to be in the nucleus. Now, this is a very important thing. When I write something in red, if I can print properly, this is very important. All atoms of all the elements have a net zero charge. All atoms have a net zero charge. So if a proton has a plus charge and the number of protons tells you how many the total plus charge in an atom, that has to equal the number of electrons, because each proton has a plus one, each electron has a minus. I'll not use that. Each proton has a plus one charge, each electron has a minus. So if you have 5 protons, you better have 5 electrons. Why? Because all atoms have a net zero charge.
So this is, I'm sorry, can I ask you something?
Sure you can.
So this is on this table that we have to learn the numbers, or
What?
so this is what we have to learn from this chart,
All
this
right,
element?
hold on. I think I see your question.
Yeah.
First thing you have to learn is the atomic number equals the number of protons. And it also equals the number of electrons in an atom. Now, I'm going to teach you in the next 2 or 3 minutes, how do you find those numbers? You don't have to memorize them. Does that help, Anna?
Yes, thank you.
You're welcome. And as always, all questions are good questions in my class, in my world, in my life. All right, before we go further, a quick commercial from Dr. White. Me. Remember the chemical symbols. They're 1 or 2 letter abbreviations for the names of the elements. Only the first letter is capitalized. And if there's a second letter, it's always lowercase. And I've asked you to know the name and chemical symbol for the following elements, like Fe is iron, Ni nickel, Ar argon, which I used a lot in grad school. F is fluorine, Cl chlorine, Br bromine, O is oxygen, P is phosphor, N is nitrogen. And let's do 2 more. Cu copper, Au gold. Ag, I lied, is silver. And instead of making you memorize all 100 and I don't know what they're up to now, 17 or not. I know it's used to be 103. years ago, and then it's expanded. But these are the only ones for my class you need to know. And what is the reason? Because these are the ones that are prevalent in your daily life. Some of the elements on that periodic table, like most of them, I have never seen, touched, or worked with. I've never had them in my life. And that means you won't either. But these, yes. All right. Now, let's first go through the periodic table, then we'll come back to this slide right here about the atomic number. All right, the periodic table. The periodic table is one of the most important, what would you call it, sources of information to chemists like me. And it was based on what's called the periodic law, which I will never ask you what that is on a test, or I don't think it will be on the final either, but I didn't write the final. All right, and that's when elements are arranged in order of increasing atomic numbers. Elements with similar properties occur at periodic, which means regular recurring, intervals. So if we arrange the elements based on an increasing atomic number, if you put that in a tabular form or arrangement, we call that the periodic table. And this is an arrangement of elements in order of increasing atomic number in which the elements of similar properties, and here it's a little more important, are positioned in the same column of the display or table. And I'll show you this later on. But this slide you do not have to memorize. Let's look at a periodic table. Everybody see the periodic table on your screen right now in green? Give me a thumbs up. Thank you, everybody. All right, this is the periodic table you will have for each of your tests that you will take at the testing center. I don't know if it will be green. I have it printed out green, and I will be sending today or tomorrow to the testing center this table so they can print it out and give it to you. Now, if you notice something interesting, the periodic table I have on the screen only has the atomic symbols, no, the element symbols, none of the names. Now, let's go to the internet first. Excuse me. All right, where did I hide it? Now, if you go on the internet, this one, which is called ptable.com, whoever made it, one of these days I'll have to find out and email and thank them, did an amazing job. This you can use for your homework, and this does have the names. If you notice, if I hold, put my cursor over in the upper left hand, you can see it expanded: silicone, oxygen, and I've got my screen too big. And let's do one more. Oh, let's go to the high rent district. And there's gold. Now, this has a lot of information. Let's go back to the one you'll be using. All right, everybody see the periodic table? Give me a thumbs up if you see it. Thank you. Now, if we look at the upper left-hand corner, right here, you'll see H. H stands for hydrogen. Now, in the box where the H is, if you look at the upper right corner, you will see a number, and that number is 1. That is the atomic number of hydrogen. and that means it's got 1 electron, 1 proton. Remember, the atomic number equals the number of protons equals the number of electrons. Now, you should be familiar with this table and where to find key elements. What's a key element? Well, one Dr. White asked you to memorize. And if we look at C, which is right here, atomic number 6, C is carbon. What's the atomic number of carbon? You look in the upper right-hand corner of the box the carbon symbol C is, and you see the number 6. And that tells you the atomic number is 6, but don't forget, really don't forget, that the atomic number gives you the number of protons and the number of electrons. So that means carbon has 6 electrons and 6 protons. Now, can you find the atomic symbol for oxygen? Oh, hopefully you all have. And it's right over here. It's atomic number 8. And I could ask on a test for oxygen, and you've got to know the symbol to use this table. Hint, how many electrons, how many protons? And the answer is 8. The atomic number gives you the number of electrons and protons. Now, as I mentioned earlier, the first time I showed you that table of those you have to learn as chemical symbols, in our universe, unless I was kidnapped to another universe, which, no, I don't think so. In our universe, krypton is not a green solid to kill Superman. It's a colorless gas. And how many electrons, how many protons does krypton have? Ooh, that'd be a good test question. Take 2 points. And what do? You have to know krypton chemical symbol, Kr. Where is it? Right here. And what's its atomic number? Look in the upper right-hand corner of the box Kr is in, and you'll see 36. And remember, the atomic number equals the number of protons and the number of electrons, which means krypton has 36 protons, 36 electrons. So sometime in your future, you might see on a piece of paper, not in red though, instant chart time. So on a test sometime in the future, you might see how many electrons and protons do the following elements have. And I have on my little table carbon, bromine, gold, and sodium. Well, what do? You look at your periodic table, and the first one was carbon. I'll give you 10 seconds to figure out how many electrons and protons does carbon have. Time's up. Carbon, chemical symbol, C. Atomic number 6. Look in the upper right-hand corner of the box where the chemical symbol is. The atomic number 6 tells you the number of protons and the number of electrons. And for carbon, that's 6. Remember, all elements have a net zero charge, so the number of protons in an atom have to equal the number of electrons. Next, bromine. Why don't you find bromine? How many electrons, how many protons does bromine have? Time's up. Bromine, chemical symbol, Br. I'll teach you later, it's called a halogen. It's all the way over here. And Br, you look in the upper right-hand corner of the box where bromine chemical symbol is, Br35. And the atomic number 35 tells you how many electrons and how many protons. Oh, let's do a high rent thing, expensive stuff, gold. And why don't you figure out how many electrons, how many protons does gold have? Time's up. What's the chemical symbol? You should know. Hint for gold, Au. It's right here. Au, what's its atomic number? You look in the upper right-hand corner of the box, and we have Au has atomic number 79. And remember, the atomic number equals and as I just wrote up here, the atomic number, this is ampersand, is shorthand for number. The atomic number equals the number of protons equals the number of electrons. And for gold, that was 79. Therefore, if the atomic number is 79, there's 79 protons and 79 electrons. I think I might have mentioned it the first day, but I better repeat it again. In high school, I had a great German teacher, Herr Brink. Herr means Mr. in German. And Herr Brink was from Germany, great teacher, funny guy. And he used to write his sevens like this, or when I was in his class. And that's the German or European way. And I thought that was the coolest thing in the world. And ever since high school, that's how I've been writing my sevens. All right, one last one to go. An important element in our daily life, and that's sodium. And what's the chemical symbol for sodium? You should know it's Na. And how many electrons, how many protons does sodium have? I'll give you 10 seconds. Go. Go. That wasn't nice. I think I gave you more than 10 seconds. Sodium, chemical symbol, Na. It's over here. They're called the alkali metals. I'll teach you that today or next week. And if you look in the box with Na, the chemical symbol for sodium, in the upper corner, we see the atomic number 11. And as it says up here, the atomic number equals the number of protons equals the number of electrons. And again, yes, the atomic number was 11. So that tells you, tells me too, there are 11 protons and 11 electrons in sodium. And I'll teach you later about sodium. It's important in our body. And I don't know about you, but when I went to my first physical, and years ago when I joined this new medical group that's really close to my house, the doctor at the time, he had to retire because of medical problems. I have another good doctor, but my general practice physician, Dr. Cantor, I went in for my physical because I just started there. And about a week later, he calls me, I've got to meet with you as soon as possible. I oh, really? What's wrong? So I went in there and had a meeting with him. I loved him and the new doctor. She's also very good, Dr. Villarosa, and she's the same old as Dr. Cantor, which is why I like her a lot too. And he was very honest with me. He said, the reason I asked you in, you've got to do some changes. What's wrong? He said, well, I did your blood test and we found your sodium levels too high and a couple other things like your blood pressure, and you're in the 90th percentile for something you don't want to be in. I said, what? If you don't change things, you're in the 90th percentile that you'll be dead in 5 years. That woke me up. Wow. And in a way, I do like being talked to straightforward. And he showed me some factors in the report on his monitor he pulled up for me that I wasn't that 90th percent. And this was more than 5 years ago, a lot more. And I changed that and I lowered my sodium level. I'll teach you more about that later in the semester. And I've done things to take off some weight. I need a lot more to take off, but that's sodium. Now, in the periodic table, there's groups, which are the vertical column. Those are up and down. And then the periods are horizontal. The more important ones are the groups. I'll never ask you what's a group or that. Now, this is important that you should know. Oh, it's even on the bottom of the slide. Key groups in the periodic table have special names. Those groups are called the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And I will be honest, once in a while, because most of my adult life, the noble gases were called inert gases until one very creative chemist found a way to make the inert gases react. And since they reacted, you could no longer call them inert, and they were changed to the name noble gases. Now, what I'm going to show you, the following you should know. In the first column, not counting hydrogen, Li lithium, Na sodium, potassium, and the rest, which we won't go through, or you don't have to know, like rubidium or cesium or francium, which I've never worked with, but I have worked with lithium, sodium, and potassium. Those are called the alkali metals. You should know, except for hydrogen, that the first column on the left of your screen are the alkali metals. And next column right next to it, magnesium, Mg, Ca calcium, strontium is Sr, but well, that's fun. I'll show you something later when we get into a certain thing about strontium that's really cool. But anyways, those are called the alkaline earth metals. Oh, excuse me, the alkaline earth metals. Now, if you go all the way over to the right, second to last column, where it has the number 7 above it, and I'll teach you later what those numbers are. I had to write them in because students I found weren't being taught Roman numerals like VII, which is the number 7 in Roman numerals. But anyways, that column with F fluorine, Cl chlorine, Br bromine, iodine, last one acetylene. No, I've never worked with, you won't either, which I'm not asking you to learn those. Those are called the halogens. Again, fluorine, F, Cl, chlorine, Br, bromine, iodine are the halogens. How many of you ever heard of halogen lights? Anyone? I see someone has. And halogen lights contain some halogen, one of these, and when you put electrical charge through it, it gets real bright. I mean, really bright. So again, first column. Oh, wait, I have one more to go. So this column with fluorine, chlorine, bromine, and iodine, those are called the halogens. And finally, the last one, helium, neon, argon, krypton, xenon, those are called now the noble gases. Once in a while, it'll slip out of my mouth, inert gas. Whoops. But those are the noble gases. And how many of you have ever seen a neon sign? The tubes that light up? It's sort of, someone has. Years ago, I had a big beer sign that was neon. When I moved to a new apartment, I gave it away because I just didn't have room for it anymore. But I had a big, I think it was just Schlitz. Most of you probably have never heard of Schlitz beer. That was my father's favorite. Having worked in Germany, I found out about good dark German beers, and American beers just don't cut it. Dutch beer that you get over there, Heineken, is better than the Heineken you get in the United States, but that's another story. All right, so you should know, first column, alkali metals. Second column, alkaline earth metals. Second to the last on the right, the halogens. The last column all the way on the right, the noble gases. I almost said inert again. And I see a question. Now I have to look at the practice problems, Anna. I don't have it called up. Well, we'll get to those when I'm through with the chapter, but I'll take a look for it. And thank you for your question. Now, if we look at the periodic table I have here, they have some of them outlined. If you click here, do you see that? Is that cool or is that cool? Now you know I'm a chemist. See how it has lithium, sodium, potassium, and so on highlighted? Alkali metals. If I go to the alkaline earth metals, you have magnesium and calcium, obviously strontium, barium, radium, etc. Beryllium. I've never worked with beryllium, but I have worked with magnesium, calcium, strontium, barium, not radium. I haven't worked with that. Now, if we go over here, they don't have the halogens marked, but if I go like this, you can see in purple the noble gases: helium, neon, argon, krypton, xenon, radon. And I've worked with a lot of neon and argon. How many of you ever gotten those party helium balloons? Or have you ever done the trick where you inhale some helium and you talk like a cartoon character afterward? Don't do it. You shouldn't do that at home. Anyways, again, alkali metals, alkaline earth metals. This fluorine, chlorine, bromine, iodine are the halogens. Why they haven't reacted nonmetals, they still should have the halogens. And finally, these are the noble gases. So on a test, if I were to ask, give the chemical symbol and the name of an alkali metal, you could write down lithium, sodium, or potassium. You could do the other ones too, but those are the ones I've asked you to memorize. If I ask on a test, 3 points or 2 points, give the name and chemical symbol of an alkaline earth metal. And you see the ones highlighted, and the ones I asked you to memorize would be magnesium, Mg, Ca, calcium. And if I say, give the name and the chemical symbol of a halogen, you could put down fluorine, chlorine, bromine, or iodine. And finally, give the name and chemical symbol of a noble gas, see historically also as inert gas. I have never seen that name, aerogens, ever. I don't know who came up with that. But anyways, the example would be helium, He, neon, argon, krypton, and xenon. You could do radon, but I didn't ask you to memorize that. Now, we've done some of this. Now, one thing I haven't talked about, I don't have it in the slide, I'll go over this more detail later, and that's the atomic mass. If we look at the periodic table you will be using, if we look at sodium, atomic number 11, underneath there's a number called 20, it's written 22.989, and that's called the atomic mass. However, I'm going to use the word mass and weight interchangeably since we're not leaving this planet, and I'll call that the atomic weight. And the atomic weight for sodium is 22.989. If we look at oxygen, right over here, atomic number 8, the atomic weight of oxygen, the number underneath, is 15.999. Now, I'm not going to go into detail about the atomic number now, because we won't be using that until material that will be on test 2. Not test 1, but test 2. Now, there are certain things that you should know, at least example-wise. And I think you've all heard in your life the term metal. And the question is, really, what is a metal? Well, metal is an element that has the characteristic properties of luster, thermal conductivity, electrical conductivity, and malleability. Say that 5 times. No, you don't have to. But anyways, what's luster? That means you can shine it up. I should one of these days clean my ring. It's been a long time, but you can take a metal and shine it up and it'll be nice and shiny. Which reminds me, when I was about 8 or 10, one of the jobs I got given from our house where I lived with my parents was, nope, it's a college ring. That's where my father wore it and some other people. So, nope, not a wedding ring. No, and I'm not married to Illinois Institute of Technology. All right, something very personal I'll show you. Can you see the date on there? 1972. That's when I got my bachelor's degree in chemistry. Wow, that was too long ago. Wow, a long time ago. All right. Now, what I was about to say is back when I was about 10, thank you. And when I was about 10, I got given the job, I think even a little earlier, that my job was when company was coming over and my mother was going to use the good silverware and some of the silver platters and everything and her silver candlesticks, I had to polish them. Oh, did I hate that? And why did I hate that? Because my mother was a stickler. I mean, a stickler about things being perfect when certain things. And polishing her silverware, she was a stickler. She was also a stickler that the lines of my bedspread had to be totally straight, or say, no, make that again. And it was good lessons for me later in life. But at the time, I didn't think so. And she'd also, besides the polish and some cloth, rags to polish it, which means you put a polish on, you rub it, and it gets off certain layers. Well, you'll learn later of silver oxide. She also gave me a toothbrush to get in the little spots like right there to get everything polished. And I hated that. Oh, did I hate that? It looked nice afterward, but I hate that. So a metal luster means you can polish it. Thermal conductivity, it conducts heat. If you cook at home, you're cooking in a metal pot or pan. That's because the flame, or if you have electric, the heat from the coil will conduct through the metal to, say, if you're going to boil water. Now, electrical conductivity, it means that a metal will carry electricity. And if you look at any of the wires, hold on, my mouse wire here, I don't like wireless mouses. By the way, I've got a good one, the Death Adler light, and by Razer, and I've had this a number of years and it's good. And the wires here conduct electricity, and the wires are made of copper, which is a metal. Now, there are other metals that will conduct. The earliest calculators had gold wires in them, and they were quite expensive. Now, the last thing is malleability. What's that? That means if you pound on it real hard, it will get thinner. A metal, if you pound on it, will get very thinner. How many of you have ever used aluminum foil? Like in the kitchen. Now, that's pretty thin. Even if you get the thick, extra strength one, it's still thin. They take a bar of aluminum and put it through rollers, putting pressure on it to make it thinner and thinner and thinner. And that's how they do it, because it's a metal. Now, just a quick side note, have you ever seen one side of aluminum foil is shiny, polished, meaning it has luster, and the other isn't that polished, it's sort of dull? You know why? Well, when they're polishing it, the thickness of the metal foil is too thin and would rip apart one sheet. So they put two sheets back to back, and on top and bottom, they have brushes or rollers that polish it. So only one side gets polished, and that's why. Now, you should know examples of metals. If I ask you, give an example of a metal, and the answer would be aluminum is a metal, copper is a metal, gold's a metal, the others lead, tin, and zinc, and also iron don't have down there, and silver would be other examples. But you should know what a metal is. And also you should be familiar with the properties. And this is more for the ACS than me. I don't think I ever asked. On a test, I'll ask more likely, give an example of a metal. Now, something that's a non-metal is characterized by, and here's the important word, the lack of the following properties. Luster. If you take a piece of Coal, which is carbon, you can't shine it up. Nonmetals do not shine up. Nonmetals do not conduct heat, thermal conductivity. Nonmetals do not conduct electricity. And nonmetals are not malleable. If you take a lump of coal, or don't ever try this at home, a diamond, you can't beat on it with a hammer or something hard to make it thin. No, it's going to crack into little pieces. And that's because it's not malleable like a metal. Therefore, we call that a nonmetal. An example of elements that are nonmetals: carbon, oxygen, nitrogen, chlorine. There's a whole lot more you could pick from. Now, I won't ever ask this, but it's an important part in our life. There are things called metalloids, and metalloids exhibit some of the properties of metals and some of the properties of nonmetals. And another name for them is semiconductors. If you have a cell phone or computer, or like I have, or my monitor or my webcam, they all have electronics in there that are mainly semiconductors. And those semiconductors, which we also call chips, are made from one type of metalloid, silicon. Now, when we talk about atoms, atoms can gain or lose electrons. So you'll have more or less electrons than the number of protons. When that happens, an atom has a charge, and we call that an ion. And ions are atoms that have more or less electrons than protons. Now, there are two types of ions: cation and anion. If I look at the clock, let me see what's next. All right, so two types of anions, cation and anion. And now that I look at the clock, it's time for a 5-minute break. I'm going to get up and stretch. I see. Is that what you'd like, Anna?
Yeah, you just tapped on the previous, I think you tapped at the metals, so we didn't see what you were talking about, but no, it's fine. Thank you.
This one right here?
Yes.
Okay, I'll leave that up for you, and I'm going to go take a break. I'll see you at 9:55. I'll be back. Hopefully you will too. I'm back. Hopefully you are too. So we're talking about metals, nonmetals, and metalloids. And then I started talking about ions. Now, ions, I'll never ask you what's the definition of an ion, but it's an atom which has more or less electrons than protons. Normally, atoms have the same number of electrons and protons, but when they don't, we call that an ion. Now, there are two types of ions. One is a cation, and the other is an anion. Now, what you should know is a cation is positively charged. It has a plus charge, and there can be more than just +1. It can be +2, +3. And this happens when there's less electrons than protons. So a cation has less electrons than protons. And I'll never ask you, how do you know something's a cation? No, but I will ask you something else, which I'll teach you how to do, dealing with cations. Now, interesting thing, earlier today, I talked about how my doctor called me in, said, you know, your sodium level is too high or your blood pressure is too high. You should cut down your sodium. Now, sodium is a metal, an alkali metal. And he wasn't talking about sodium. What he was talking about is the sodium cation. And that's what he was talking about. Now, if you notice, when you write a cation, you write the chemical symbol and then upper left, upper right, excuse me, superscript right, you have a plus. Now, if it's something like calcium, that's a +2, which I write the old way and the newer way, which I don't like. And this is the ion calcium forms. Now, how many of you heard you need to have enough calcium in your diet for strong bones? Well, they're not talking about the alkaline earth metal, calcium. Are you going to eat things like metal, like my ring? No, you'll break your teeth. Don't do that. Don't do that. What they are talking about are calcium ions, and that's what keeps your bones strong. And that's an ion, which is a cation. Now, the other type of ion is called an anion. Anion. And an anion is negatively charged. And that means it has more electrons than protons. Now, in salt, sodium chloride is, I'll teach you later on, is an ionic compound, meaning it's made up of ions. And it has sodium plus, and the anion is chlorine. That's an L right there. I don't cursive L's good or non-cursive, but that's Cl, chlorine. And this tells you it's an anion. Plus charge, cation, negative charge, anion has a negative charge. Now, there's something, I'm going to turn the switch totally off, click, called isotopes. And those are atoms that of the same element that have different number of neutrons. They have the same number of electrons and the same number of protons, but they have different amounts of neutrons. And switch is totally off. I've never used this. One way of showing that, it's called the nuclear symbol. You have the chemical symbol, and to the left, superscript. You have the mass number, and then under here, you have the atomic number. Now, the mass number and the weight are slightly different. I should have mentioned this earlier in real life. Now, true atomic mass is the number of protons and neutrons in the nucleus. Again, switches off. This won't be on a test of mine. So that's the atomic mass. Well, I see where I made a mistake. Atomic mass number is the number of protons and neutrons. Now, if we look at the atomic mass, which I call the atomic weight, again, switches off, the weighted average mass of all naturally occurring isotopes of an element I'll have to let my voicemail pick that up. One more ring, I think. Stop. Ooh, it listens to me. Hi, Anna, you have a question? Go for it.
Yes, so about that switch, like you said, when the switch is off, it's not gonna be on the test. But my problem is like the last exam, number 5, right? It's now like your test. So we don't know what we can expect, right?
Well, there's a couple of things, and that's a good question. Now,
Yeah.
my test number 5 will be comprehensive. It will cover all the materials I covered on tests 1, 2, 3, and 4. Can you keep a secret? Don't tell anybody. But I have my test number 5 comprehensive because that way I can keep the American Chemical Society final exam down to the minimum amount of points I have to do for the active course file. And the ACS final exam is, how should I say this, not the best written exam or final. It's written by a committee from the American Chemical Society, and it's used at a lot of colleges throughout the United States as a final. Now, what I can tell you, why I say it's not good, well written is, last time I checked, I think the average for the years, I forgot when it was, a number of years ago I checked, for all the United States, all the students taking that ACS final was out of, I think it's 60 questions, the average was 27 right. And that just tells you either everybody's really dumb, yep, I'd use that emoji, or it's poorly written. It's just meant to trick people more than show what do you know. And we're forced to give that, but they have in the active course file, it's only 5% of your grade. So, and I also curve it heavily. Don't tell anybody. But that's why now the ACS final will be similar to my test. The questions on there, except they're multiple choice meant to trick you. I don't use, on test 1, I think I might have maybe out of 100 points, 10 points multiple choice, which there are certain questions that are good to put down in multiple choice where they're not really meant to trick you, but you show me you know this. But on the ACS, they play games to trick students. And I don't like that, but I don't have a choice. Does that help you, Anna?
Yes, so let's say I'm gonna have 0 points from that, the worst case, and it's not gonna really do anything to my grade if I'm gonna pass your exam.
Well, if you're already getting a good grade,
Yeah,
5%, and you do somewhat decent on that, it won't hurt your grade.
okay, thank you.
Don't tell anybody.
Okay, I won't.
Secret. It's a secret. All right. So anyways, we're talking about the atomic mass, and that's taking the atomic mass number and doing a weight average. So the atomic mass, which I call the atomic weight, is an average of all the different atomic numbers of an isotope. Now, if you look at carbon, you see it's 12.011. How did they get that? Well, there are different isotopes of carbon, like carbon 12, carbon 13, carbon 14. And the most abundant isotope is carbon 12. Let's go out. I haven't done this in a long time. And you can see there's a carbon 13, carbon 12. I've never heard of carbon 16, but if we go to Wikipedia, there are a whole bunch. Well, I'm not finding. This is what I should have had. All right, everybody see on the screen, carbon 12, that's how they put 12C, has abundance of 98.8%. So you do 12 times 98.9 plus 13, 1.1, and that's how they get the atomic weights or mass. Again, switches off on this. Whoa. I think we just run through chapter on this chapter. But anyways, the atomic mass, there's a way of calculating it. Now, I know some instructors will put on a test, if there's so much of this isotope and this is of this, what's the atomic weight or mass of that element? And guess what? Other than I was a freshman in college taking intro chemistry, general chemistry, I think we had to do that on one test. I have never done that in my whole chemical career. Remember, I've worked in the chemical industry out in the real world. You don't do that. You look at the periodic table. So I will never ask you to calculate the atomic weight of something. You look at the periodic table. Speaking about looking at the periodic table, let's look at it again. Now, we won't be using this for a while, but what's the atomic weight of nitrogen on this periodic table? Well, you look underneath and you see 14.007. That's the atomic weight or mass. I'll use weight. And if you look at, here's one. Why don't you find out what's the atomic weight of iodine? And hopefully you all learned or will learn, hint, that iodine, which is a halogen, remember this column right here, iodine, the chemical symbol I, and the atomic weight is 126.904. And remember, the atomic number is 53. The atomic number tells you number of electrons and protons, but the atomic weight is a number we'll learn from when we cover material that will be on test number 2, how to use that. And that's a quite useful number. And if we look at sodium, it's 22.989. Sodium chemical symbol. Na, atomic weight, the number underneath the chemical symbol. All right. Now, we finished chapter 4. I think we finished everything that will be on test number 1, but let me check, and I'll get back to you on when we meet again on Tuesday about that. But let me open up something that I need to do.
Can we maybe do some practice problems from chapter 4 so we're gonna like close the test number 1?
We'll do that next week. I try and give everybody some days to do the practice problems before I do. Okay? Actually, we're ahead of schedule, but don't forget, next week I'll lose Monday, so we're pretty much on schedule. Let's do this. Give me a second while I look at something else. All right. I'm glad I looked at it. What I was just doing was looking at my syllabus, because what I've done this semester, and I've taught it before, is I've jumped around, so it makes sense. All right, Jasmine asked a question. To be clear, we won't have to calculate to find the atomic mass of an element. And the answer is yes. Yes, you will not ever have to do the calculation to get the atomic mass of an element in my class. I haven't done it ever in my career, and I don't see the benefit of having a student do that. It makes no sense. No chemist who's an industrial chemist, and either same thing with even academic chemists, if they need to know the atomic weight of an element, you go and look at the periodic table. That's one of the 2 key functions, or there are more, but that's one of the 2 most important functions of the periodic table. And thank you for your question, Jasmine. And as I say, all questions are good questions in my class and in my universe. All right, well, we finished chapter 4. We're moving along quick. Now, listen carefully. Next Tuesday, I'll go through chapter 3 problem set. You should do it before I do. Next Tuesday. Also next Tuesday, by this weekend, I should have it up, Monday at the latest, even though I like to take Monday off, but I'll probably Sunday. I'll have the lab for Tuesday's lab, where you will be using your chemical kit that you should have ordered. If yours is late, let me know. It's happened before. During the pandemic, the first time we used the kits, the bookstore, I'm not going to get into that. And some people got the kits like 2 weeks late, but they had time to catch up. That's the case. I'll allow people to hand in things late if you don't have your kit yet. Well, hopefully you've already ordered it and it should be there or on your way next couple of days. All right. And what I did while I was talking to you is I called up my syllabus. I looked here and said, oh, we're supposed to be doing chapter 9. So I jump around in the book because it makes more sense to follow my order than what's if you're using the book. So guess what time it is? It's new chapter time. Now, we've covered all the material for test number 1, but next week I'll go through the practice problems on Tuesday for chapter 3, and the following Tuesday before the test, or better yet, let's make it next next Wednesday. I used to teach this on a Tuesday, Thursday, face-to-face, so I'll say that once in a while. Next Wednesday, we'll do chapter 4 problem set. Oh, hold on. It's fixed now. Uh-oh, it's broken again. We'll do chapter 4 next Wednesday. Next Tuesday, we'll do chapter 3 problem sets. Okay? Speaking about problem sets and everything, I'd like all of you to think about it. Right now, on Monday and Wednesdays, I have my office hours from 5 to 6:15. Now, at the other school, I teach on Monday and Wednesday from 1 to 4 approximately. So I don't have time to have an office hour during then. But what if you think another time on Monday afternoon or evening after 4 would be more convenient for you personally, email me. Again, if there's a better time for you to come to my office hours, email me. And if enough people want a different time, I can change it. I have that power. All right. Everybody see chapter 9 on your screen right now. Thank you, Rochelle. All right. Now, this will not be on test number 1. It will be on test number 2. And this talks about electrons in atoms and the periodic table. And one of the questions you may have had is, well, if the protons and neutrons are in the nucleus, the center, I make it look round, where are the electrons? Well, they're not in the center, they're all around, but they're not just floating around like planets. People tend to think that. No, it's a lot more complex. So where are the electrons in an atom? Good question. Thank you. And in order to answer that question, I have to give you a little background information. First of all, in our universe, in our world, we have something called electromagnetic radiation. And this is energy that travels waves, just like the waves come in from the ocean or Lake Michigan. I haven't been to Lake Michigan in a long time. I haven't been to the Pacific or Atlantic Oceans in a long time either. But I remember like one time when I was in California, boy, surf was in, meaning there are big waves, really big. Well, the energy that travels in waves through space are called electromagnetic radiation. By the way, click, switches off, but this is good background information to help you understand something when I turn the switch on. Now, since it's a wave, we have something called wavelength and frequency. And electromagnetic radiation is like the ocean waves. It has a wavelength, which in chemistry and also science, we call lambda, the Greek letter lambda, and it has a frequency, which you use the Greek letter nu. And are you ready for this? Time for a really bad joke from my college days. Well, first, there's a mathematical relationship between the wavelength and frequency. And the frequency is equal to the speed of light divided by the wavelength. And you don't have to know this. Now, are you ready for the bad joke? V is really the letter nu in Greek. And when I was in college, somebody would come up to me and say, hey, Dr. White, I wasn't Dr. White then. Hey, what's new? And I would answer, C over lambda. Did everybody get the joke? What's new? C over lambda? Never mind. Now, when we talk about electromagnetic radiation, there's a concept called the electromagnetic spectrum. And that's a arrangement, again, switches off still, of all the forms, various forms of electromagnetic energy in order of decreasing energy. If you had the book, would be here, but we've got the internet. And if I were in a classroom, I'd be pulling this up now. That's what I was looking for. All right, everybody see this on your screen where it says types of electromagnetic radiation? Maybe you can't. Hold on. Thank you. Now, if you look there, going from right to left, as you go from, or I should say, when you go from left to right, you go from less powerful electromagnetic radiation or energy to more powerful. Now, if you notice right in the middle is visible light. And that's made up, how many of you remember from high school, you had to memorize Roy G. Biv, red, green, etc. And the different colors of the rainbow visible light all come together to make white light, not named after Dr. White. Oh, that was bad. But anyways, you have the different energy and they have different wavelengths. Now, if you notice, if you go higher, it's ultraviolet, which can cause serious skin damage. X-rays is quite powerful, and gamma rays are very powerful, used to kill cancer. And if you watch the movie The Hulk, gamma rays turn Bruce Banner into the Hulk, which isn't real life, but still very interesting cartoon character, became a Marvel superhero. But anyways, let's try something here. And if you see on there, I brought in the visible light, which shows the spectrum. And this is flipped around from when I showed you. And you can see these have different color light, have different wavelengths, and this is called the spectrum. I don't know about you, but I have a couple of prisms I got. Oh, I think my father got me in high school. They're really big. They're like this, and I still play with them once in a while. You put white light through it, like sunlight too, it will separate it into the rainbow there. Well, why am I talking about this stuff? Well, let's find out. All right, and like I said, the electromagnetic spectrum, here are the different types of them. I just showed you that. Now, it turns out, and let me just fix something on the slide. We have something called atomic spectra and energy. Now, atomic spectra is when light is emitted from heated elements that pass through a prism. And this is also sometimes called a emission spectrum. So if you take an element and heat it up very hot, it will give off energy. And that energy is in the form of light. And different elements give off different what's called atomic spectra, because the types of waves or energy that comes from heating those elements in the form of light are different wavelengths. Again, switch is still off. And if you look on your screen here, you'll see on your right, hydrogen has these different colors that make up the light from hydrogen when you heat it up. Neon has these colors. Now, one you're probably familiar with is sodium. Now, they show the colors, but some are stronger than the other when it is. And notice sodium, most of them are yellow. How many of you have ever boiled water that you put some salt in there? Have you ever done that? Nobody? Do you people cook out there? Well, if you ever have salt in water, like if you're making noodles or other types of pasta, and it boils over a little, some of the water, if you have a gas, I like that, gas flame underneath, you'll see the blue flame from your gas become yellow. Let's see something. I may have to do it for next week. Let's, hold on, we got time. This is the first time I've ever done this in a class, so hang in there. All right, there's something called a flame
We're gonna do a
test.
flame test.
And let me do this. Does everybody see the YouTube on the screen right now, the video? All right, this is called a flame test. And that's because different elements, when you heat it up, give off different colors. And since all organic chemists, when they're young, me included, we're pyromaniacs. Let's have some fun.
We're going to do a flame test on a number of selected compounds, primarily group 1 and 2 ions. And these are aqueous solutions, and we have just a inert metal loop. We're going to dip the end into the solution and put it into the flame. And that excitation characteristic color is like a fingerprint for an element. So we're going to look at a number, and then we're going to ask you to identify some unknowns.
Ooh.
Potassium. It should be a lavender. This is barium. It's green. This is calcium. Calcium. With a yellow red.
Tell me she's not going to do sodium.
Strontium.
This is my favorite. Watch. I have to find a better video because it's a beautiful red flame.
Lithium.
Oh, maybe she will get the sodium.
Sodium is a bright yellow.
Yay. So when you boil water with salt in it, it has sodium cations, and it gives off that color
Last one
from the
is-
atomic spectra. Here's copper. This will be nice
this
too.
is the most vivid of all of them. That's green.
If you want to ace,
All right, so we have what's called, hopefully you all enjoyed those. I had a good time watching it. But then again, I'm a pyromaniac. When I was younger, I still have some in me. It looks cool when you burn certain things. Now, the atomic spectra, if the color light that you saw from the flame, if we had passed that through a prism, you would see a couple of bands of different colors that come together to make the color you saw. And this is called the emission spectra also. Now, what this shows was that the electrons, that's what you're seeing causing the color, are moving at different levels in the cloud of the atom. And when you're adding heat, you cause them to go to a higher level. And as soon as they go outside of the flame, they're saying, I don't want to be here. They move back to where they were. When they move back, they give off energy. And that energy is light. Now that taught chemists that the electrons are in certain places that have a certain amount of energy. When you add energy and move them away from that place, they'll move. But when you take the energy away, they'll come right back to where you were. Now, switch is still off. A great chemist, Dr. Bohr, came up with a model. And the model was, where are the electrons? And the first thing is they travel around the nucleus at fixed distances and switches off. And the orbital has what's known as a quantum number. The quantum number is what level or energy level are the electrons. And the energy between each orbit is fixed, and that's called a quantum of energy. I know this is going to seem confusing, but I'm just sort of going through it a little quicker to get through everything before we stop. I'm going to come back to this on probably Wednesday. Remember, this is for test 2, not test 1, and this won't be on test. And electrons going from higher orbit to lower orbit give off what we call photons of energy, which was the light you saw when those were burned. So think of it this way. There are certain distances from the nucleus that have a certain energy level associated to it. And those energy levels or distance, they're called quantum numbers, where they are. And when they change, you can get different energy. Now, if I look at the clock, we're just about done today. So before, I'm going to let you out a whole minute or two early. Shh, don't tell the dean I'm doing. Well, actually, it's a net course. I don't actually have to do this, but I will have lectures. All right, couple important things. All of you should be doing the practice problems. If you do the practice problems and can do them correctly, you should be able to do quite well on my test number 1 and all the rest of the tests. So between now and next Tuesday, if you haven't done chapter 2 practice problems, you should. If you haven't done chapter 3, I'll go over that on Tuesday. And then Wednesday, I'll go chapter 4. Do the practice problems. They help you get a good grade. By the way, if you get a good grade, I get what I want. You've learned chemistry. Now, the other thing is, as I mentioned earlier today, sometime today or tomorrow, I will post an announcement to tell you to go to the assignment area of Blackboard, and I'll have a form that you have to sign in a couple of places. Scan it or use your cell phone to take a pictures using an app, or I also have instructions how to do it on your computer to make the PDF file. And I'll need by the end of next week, if not sooner, not this week, next week, that you sign that. Actually, I'd like it before Tuesday, that you sign that and upload it. And in fact, I'm going to do something sneaky. Once you upload it, I get it, I'll give you 2 bonus points. Everybody who uploads it before next Tuesday, the form, you get 2 bonus points. How about that? That will get everybody moving. Thank you, Alexis, and everybody. Yep, I do that, Jasmine, too. So don't forget, sometime probably before I go to bed today, I'll get that up and you'll be able to. And if you do it before next Tuesday, you get 2 bonus points. Also, don't forget, Monday is Labor Day, no class, no office hour. Just enjoy the holiday. And with that, I'm going to let you out a whole 60 seconds early, even though I don't have to have lecture at all. And I'll wish you a happy rest of the day, rest of the week, weekend. Have a happy Labor Day weekend. And with that, gang gesund. Bye now.